Hey guys, welcome to another episode of Crimes Notes. Today we are going to be talking about how to solve cubic equations. So let me get my screen size just right and we will get started. Please know that this is going to be a little bit of a review. Remember, we've already talked about how to solve quadratic equations, and we've also talked about how to solve square root equations. So the steps are going to be very, very similar to what we've been doing before. So again, today we are going to be solving cubic equations. By the end of today, you should be able to solve a cubic equation for one variable with one of two methods. And then I'm going to give you a couple of practice problems along the way, and hopefully you guys will be able to figure out how to solve a cubic function. And again, this is algebraically. I will show you graphing later on this week. So first and foremost, solving equations with one variable. The first thing that you have to do is look to see if there's more than one variable in the equation, meaning is there an x squared, is there an x? So later on today, in fact, let me pop down, notice right here, you're actually going to see that there are equations that have numerous x's in them, but that's not what we're talking about right now. So first of all, here's our equation, 3x cubed minus 24 equals 0. There is only one variable in this equation, it is x, okay? So then use inverse operations or reverse the story of x to isolate the cube. And again, the words that I have in blue are the ones that you have as a question mark. So make sure that you are filling those in. So again, we're going to isolate the cube. So the first thing that we need to do is move this 24. And again, remember we talked about the story of x. So the first thing we did was cube it. Then we multiplied it by 3. Then we subtracted 24. So if we reversed it, the first thing we would have to do would be to add 24 on both sides. If I do that, the result, these would cancel out and I would get 3x cubed equals 24. From here, the next thing that we did was multiply x by 3. So the opposite would be to divide both sides by 3. Then over here, the 3's would cancel, leaving me with my x cubed. 24 divided by 3 would give me 8. So now I have that cube isolated. Once isolated, we're going to cube root both sides. And again, that is because the opposite of cubing is to cube root. So notice I've got the cube root of x cubed, and I have the cube root of 8. So on this side, the cube root and the cube are opposite. So literally these two things would cancel out, leaving me with just x. And then we could put the cube root of 8 into our calculator. And if you needed to, you could go into Desmos if you wanted to, okay? We could go over here, and of course I have some random stuff in there. But if I put in QBRT for cube root and I put in 8, notice it tells me that the answer is 2. So if I were to go back to my slides, I would know that the cube root of 8 is 2. So again, that last step is solve for the variable, and we do that by cube rooting and simplifying on both sides. Okay, so the very next slide leaves you one to do on your own. It's very similar to the one that we just did, so I have confidence that you guys are going to be able to work your way through that. So now, what happens if we get a fraction? So we're going to follow the same steps. We're going to see if there's more than one variable, and if you notice, we still only have one x cubed. So we're going to use our inverse operations or the reverse story of x to isolate that cube. So the first thing I have to get rid of is this negative 8. So the opposite of subtracting 8 is to add 8. I don't know what I pushed. Apparently we're going to equal 8. Whoops. 8. There we go. And we're going to add 8 on this side. If I do that, these two would cancel out, leaving me with negative 27x cubed, and then 0 plus 8 would leave me with 8. Then the next thing I would need to get rid of is this negative 27. It was multiplied, so we multiplied by negative 27. So the opposite would be to divide by negative 27. And so this is where it gets kind of interesting. If I try to divide 8 by negative 27, it's not going to come out evenly. And so we are just going to leave it as 8 over negative 27. Again, if it doesn't reduce evenly, we're just going to leave it. So now on the left side, we do have this cube isolated. So we would be ready to cube root on both sides. So if I cube root on the left, okay, the cube root and the cube cancel, leaving me with x. But over here, if I cube root on this side, and if I were writing this, I wouldn't do two separate cubes. I would do one giant cube over the whole fraction, but that wasn't something possible for me to type. So I just went ahead and did it separately. So I'm going to put these in. I'm going to take the cube root of 8 and the cube root of negative 27. Well, we already know that the cube root of 8 was 2. Let's go back over to Desmos and see what it says about the cube root of negative 27. So again, I already have that cube root there. So let's go back under here and put in negative 27. Notice it tells me negative 3. So we're going to go back over to our slides and we would put this in as negative 3. So my solution here is actually x equals 2/3, negative 2/3. Like you could actually rewrite this. Let me come off to the side here. This could actually be negative 2/3. I guess I need to not center that. And then put this back where it goes. There you go. So, but 2 over negative 3 is the same thing as negative 2/3. Okay. So, as usual, like what we were doing before, I've left you one to do that's going to end up having a fractional answer. I want to see how you guys do with that. All right, so what happens when the answer to that question, look to see if there's more than one variable, ends up being a yes? Okay, so notice now, instead of just having the x cubed, I have an x squared and I have an x. So the next thing that you're going to do is count the terms. So here I have 1, 2, 3 terms. If there's 4 terms, we're going to factor by grouping, which we will look at in just a second. In this case, if there's less than 4, we want to factor out the GCF first and then factor. So remember, the GCF is the greatest common factor. So we always start with the lowest whole number, so 5, and we see if all the numbers divide by 5. 30 divides by 5, 5 divides by 5, and 25 divides by 5. So we would use 5. And then we have to figure out how many x's they have in common. Well, there's 3 here, there's 2 here, but there's only 1 here. So they would only have 1 in common. So right here, this 5x would be our GCF. So if we divide that out of each term, what would we have left? So 30 divided by 5 is 6. If I had 3 and I take out 1, then I would have x squared. And again, I'll fix that in just a second. Then I have a positive 5 divided by 5, which would be positive 1. So I'm not even going to put the 1. I'm just going to put x. If you do, we can put the 1. I mean, it's not going to change anything. And then the last one is negative 25 divided by 5x. So this would be minus 5. And then x divided by x would leave me with nothing if I suck it out. So again, I'm going to highlight this and hit control period so that it looks like an exponent. So now we have this, which we would now need to factor the rest of the way. So if I go in and I've got to multiply a times c, right? So 6 times 5 is 30. Well, negative 5 is negative 30. So I would need factors of 30 that would make 1. So they're going to have to be really close together. So 1 and 30, that's going to make 31 or 29. 2 and 15, still not going to make 1. 3 and 10, that's going to make 7. 4 doesn't go into it, and then 5 and 6. So there it is, 5 and 6. And in order for this to be positive, we would have to do the positive 6. So I'm going to do 6x plus 6. Remember, all we do is take that first term, so 6x minus 5. So again, we can double check. 6 times negative 5 does give me the negative 30. 6 minus 5 does give me the positive 1. So now we're supposed to see if it reduces, right? Because we know 6x times 6x makes 36x squared. It's too big. Well, obviously, this one does divide by 6. So that would leave me with x plus 1 for that one. And then this one does not simplify, so we would have 6x minus 5. So we've counted the terms. If it's less than 4, we've factored out the GCF and then factored. Step 4, we're supposed to set each factor equal to 0. So notice I did the first one, 5x equals 0. Our second term, we would do x plus 1. So x plus 1 equals 0. And then the last one, we would do 6x minus 5. Whoa, that's not a minus, sorry. Equals 0. Then from here, we're supposed to solve for the variable. So again, we reverse the story of x. So this is 5 times x, so the opposite would be to divide by 5. And if I do that, 0 divided by 5 is still 0. For this one, we could subtract 1 on both sides. So then 0 minus 1 would be negative 1. Then on this one, we have a minus 5, so the opposite would be to add 5 on both sides. If I can type correctly, whoops. Plus 5. There we go. I don't know what I did. I got some funky formatting happening. There we go. Okay, so then these would cancel. 0 plus 5 would give me a 5 here. Then I've got 6 times x, so I would have to divide by 6 on both sides. So my answer would be x equals 5 over 6. And remember, if it doesn't come out evenly, we leave the solution as a fraction. So in this case, this cubic actually would cross the x-axis or cross looking for those roots 3 separate places at 0, -1, and 5/6. Okay, so again, this is if you have 3 terms or if you have a GCF. It doesn't necessarily even have to be 3 terms. All right, so now let's look at the one that I was talking about before. What if you count these terms? So notice we have an x cubed, an x squared, and an x. So we have more than one x term. So if we count the terms, in this case, I've got 1, 2, 3, 4. So there are 4 terms. So that means we are going to be factoring by grouping. And I'm not really sure if this is something that you've actually done before, but we're going to kind of talk about it. So when you factor by grouping, you're actually going to split the problem into 2 and 2. So the x cubed and the x squared are going to go together, and then you would kind of think of it like drawing a line right here in your problem. Okay, and then you're going to put the other 2 together. You guys can't even see that line. I better make it a little bit darker here. So we're going to look at these first 2 terms, and we're going to try to figure out what they have in common. Well, they don't have a 2 in common. Okay, so we really can't take that out. This has 3 x's and this has 2 x's. So if you notice, they have an x squared in common. So again, if we use that vacuum effect, right, we're going to suck out an x squared. Well, if I do that, I have a 2x left, right? And then I would have a -1 left, okay? This may need to be a little bit smaller font or I'm not going to get this all in there. So we're going to make it smaller. All right, so now I look at the second two factors, and I didn't mean to cover up that sign, so let me kind of move that. I have a positive 2x and a -1. Well, in this case, they don't have a 2 in common. They don't both have an x. So if they don't have anything in common, we're always just going to say that they have a 1 in common because everything has a 1 in common. And then you're basically just going to type what you see. So 2x minus 1. Now, I will tell you, if you do it correctly, these sets of parentheses should be correct. Okay, they should be exactly alike if you did factoring by grouping correctly. So now what you're going to do is you're going to take this term that's outside of the parentheses. Let me see if I can highlight it like green or something. Okay. And then we're going to take this term that's outside the parentheses. And again, I think we'll highlight it green as well. Okay. And we're going to take those and make one term. So notice I brought down x squared and a +1. The other term is going to be whatever was inside the parentheses, so 2x minus 1. And now it's exactly like our other problem. We're going to take this factor, set it equal to 0, and we're going to take this factor, which I can now type in as 2x minus 1, and set it equal to 0. And again, I don't know why I added the parentheses there, because once you split them, you don't really need them. I think it's just out of habit because they are factors. Okay, take those out. All right, so now we would subtract 1 first on this side, right? Then if I do that, I get x squared, 0 minus 1 equals -1. Then I'm going to square root x squared, and I would square root -1. Well, that ended up being interesting, right? This ended up as I. Ooh, and it should be a lowercase I. I'm not really sure how to make that a lowercase I. I might have to change the font. Let's just do that, just so it'll show you that it's actually an I. Because remember, the square root of -1 is I, which means this would be imaginary. So now let's look at this one. So this would be a +1. And this would be a +1. And so I would get 0 plus 1 is 1. These would cancel, leaving me with 2x. Then I would have to divide by 2 on both sides. Let's get that over. And then 1 divided by 2 is 1/2. So we could put in 1/2. And that would be what we would get. Now, again, if we were to graph this, you would only see it cross that x-axis one time at 1/2, which means the other solutions would be imaginary, which is why you don't actually see them on the graph. Okay, and remember, this is positive or negative, plus or minus I. It's just kind of how it works. Okay, so that is factoring by grouping. So I've left you one problem like that for you to try, that is the factoring by grouping. Again, if you're looking at these first two factors, there's not a number that we can pull out because the 3 and the 2 don't have anything in common, so you'll pull out the x squared. But for the -12x and the -8, they do have a -4 in common. So you would want to pull out a -4 and see what you have left. Do please feel free to type out your work if you want to, but if it's easier, please feel free to do it on a piece of paper, and then you can just post a picture. So I hope that gets you through how to solve cubic equations algebraically. Remember, if you need anything, make sure that you just ask. And until then, I will see you next time. Have a great day.